Hello viewers, so here we'll look at example 5 and example 6 in this video where we will find the vertical asymptotes analytically without graphing. So if you look at this question, it says the sum of the vertical asymptotes. We're looking for the sum of the vertical asymptotes of which graph? Of this graph. But here we don't have to graph. So remember, this graph is the same thing as minus 1 over what? Sine x minus 3 over this one. This is the same thing as this. So if you want to find the vertical asymptotes, it's just going to be the zeros of the denominator. So this will just be sine x over 3 minus pi over 6. This is equals to 0. And this, what does that mean? It means that x over 3 minus pi over 6 has to be what? N pi, where this n can be any integer. And now what does that mean? We can multiply both sides by 6. So this will become, if you multiply by 6, this will be 6 times x over 3 minus pi over 6 times 6. And this is equals to 6 times n pi, which is the LCD. So I use the LCD, which is 6, right? So this will become 2x minus pi is equals to 6n pi. And I can solve for x. So this will be what? 6n pi plus pi. And it means that x, it's simply, you can take n as pi as a common factor. So you have 6n plus 1 over 2, right? And here you have n is in z. So this gives us now the general formula for all the vertical asymptotes for this function. But here, specifically, we are told that we need only the vertical asymptotes that are between which interval? These two intervals, minus 4 pi and what? To 2 pi. So how do we solve this one? We need our minus 4 pi. We need x to be between minus 4 pi and what? 2 pi. Then what is the x? We already know what is x. X is pi into 6n plus 1 all over 2 less than equals to what? 2 pi. And we need to solve. Then we can multiply both sides by 2. So this is minus 8 pi less than pi. And this is 6n plus 1 less than 4 pi. And if you look carefully, you can cancel the pi from everywhere. So you just have just this, because pi is common. So you can divide through all by pi. And now we solve for n. This will become minus 9 is less than 6n is less than 3. Am I correct? So we subtract 1 from the three-sided inequality. So it means we have minus 9 over 6 is less than equals to n is less than 3 over 6. And this is minus 3 over 2 less than equals to n less than 1 over 2. So it means that if you're on the number line, this is minus 3 over 2 and 1 over 2 is somewhere here, right? Am I correct? So we see that how many possible zeros can we get? Not possible zeros, how many integers can we get here? Now, if you look here, if this is minus 3 over 2, then somewhere here she's going to be minus 1. And also here is going to be 0, right? So the only integers we have between minus 3 over 2 and half are just 2. N equals to minus 1 and n equals to what? 0. So these are the only two integers that we can get in this range. So now we need to go back to here and substitute. So if n is equals to 0, let's start with the smallest one. If n is equals to minus 1, what is x? X is going to be pi minus 1. So it become minus 6 minus 1 over what? Over 2. And this is going to be, I know this is plus 1. So this is minus 5 pi over 2. So if n is equals to 0, we will have what? Pi just 1 over 2, right? So which is just pi over 2. So we have two vertical asymptotes. So our solution set for the vertical asymptotes are just this one, minus 5 pi over 2 and pi over 2. So, but the question is asking for the sum. Let's go back. The question says we look for the sum, right? So what will be the sum? The sum will just be minus 5 pi over 2 plus pi over 2. And this is minus 4 pi over 2, which is just minus 2 pi. So for the next example, it says find the number of what? Vertical asymptotes. So this is asking for the number of vertical asymptotes. It means how many vertical asymptotes can this graph get between 0 and 3 pi. So you could graph it and check. But if you don't want to graph, then you do this analytical method. But remember, this is what? This is the same thing as 1 plus 3 over what? Sine 2x plus what? Plus pi over 3. This is the same thing as this. So it means if you are looking for the vertical asymptote, it's simply you take sine 2x plus pi over 3, you equate this to 0, and this means that 2x plus pi over 3 is still going to be n pi. Remember here we are all dealing with cosec, right? So if here we happen to be sec, then you need to use what? Cosec. You need to use the zeros of what? Cos. And what is the zeros of cos? If cos x is equals to 0, x has to be what? Pi over 2 plus n pi, right? So let's continue here. But since we are dealing with cosec, we are still using sine, the zeros of sine. So here we can multiply by 3, so that here becomes 6x plus pi is equals to what? 3n pi. Yeah. So it means that 6x is equals to what? 3n pi minus pi. So 6x is what? You take pi out, you will have 3n minus what? Minus 1. So x is what? Pi over 6, 3n minus 1. And this is n is in z. So we have this one. Correct? Okay, yep. Now, the same way, we want to see what is, we want our x to be between 0 and what? 3 pi. We're using this interval now. So this means that 0 needs to be less than x, which is pi over 6, into 3n minus 1, less than 3 pi. So you multiply both sides by 6. This is still 0. This is pi. 3n minus 1 less than equals to 3 pi. No, not 3, but 18, because we are multiplying both sides by 6. So this is 18 pi. Now you can divide both sides by pi, actually. So here will still be 0. Here will become 3n minus pi, and this will become what? 18. Then we try to solve for n. Here will become 1, 3n, and this will become 19. So we're adding 1 to the three-sided inequality. So if you divide both sides, so this is 1 over 3 is less than n is less than 19 over 3. So it means that our n is between 1 over 3 and 19 over 3, right? So when we say 1 over 3, so what are the n here? For example, you have 1 here. No, you can't have 1 here any longer. If this is 1 over 3, then yes, we can have 1 here. And then what n can we get here? 19 over 3 is greater than 6. So the last integer here is going to be 6. So it means the n can be 1, 2, 3, 4, 5, and 6. So these are the possible n, right? So it means we're going to have our answer to be 6. Because remember, this question is not asking us to find the vertical asymptote. It's asking us how many vertical asymptotes. So the value of n is okay. If the question were to find the vertical asymptote, then you now have to come back here and substitute n is equals to 1, n is equals to 2, n is equals to 3, like that. But here we don't have to do that. All right, so I hope this is clear. This is how to find the vertical asymptote, and what do you call it, analytically without graphing. And just like I said, in both questions here, we dealt with what? Cosec, right? So if you have sec, it's the same thing. You just need to use the zeros of sec, not the zeros of cosec. All right, so I hope this is clear. If you have any question, you can put it in the comment section. So in the next video, we'll see how to obtain the graphs of cosec and sec, how to obtain the equations from the graph. So thank you for watching. If you are yet to subscribe, kindly do that and turn on your notification bell. Also share with your friends.